Now I want to welcome Dr. Tewes Tralau. He replaces today Tanja Schwertle, the Vice President of the Federal Institute for Risk Assessment, because of an accident, and we are glad that you were able to come. Tewes Tralau studied biology in Constance and started working at the BFR in 2010 in different topics like food safety, chemical safety under REACH and consumer-related products. And since August 2020, he's the head of the Department for Pesticide Safety at the, before he moved to the BFR, he was very involved in research in many places: Manchester, Shanghai, Strasbourg, Oxford, and Grenoble. And yes, he's international, very active, and a scientific expert for the development of toxicological assessment concepts. Thank you for coming, and we are looking forward to your talk.
Yeah. Thank you for this kind introduction, and thank you for the organizers for giving the BFR an option to speak here. And a good day to you, ladies and gentlemen, here in the room and joining us from outside and bringing up the energy post-lunch to listen. So, health-based guidance values. A lot of it was said before. I'm going to give a little bit of perspective from the viewpoint of a toxicologist who is involved in risk assessments. And it's important to remember that exposure is basically half of what a good risk assessment consists of. And for that, we need reliable estimates. And here, HBM can, of course, support such estimates, either by validating the respective theoretical prediction models or by allowing comparison of measured data to health-based guidance values. However, we have to keep in mind that no matter how good the HBM data are, they can never replace really the risk assessment and the exposure assessments done ahead. And the problem there is, or it's not a problem, it's basically an inherent limitation that when you measure data in human blood or urine, that you don't get a clear answer to your question where the exposure comes from. And unless you do untargeted analysis, you always will have also the problem that you can only act retrospectively, which of course for many questions is fine. We were thinking hard of a good example where HBM in terms of toxicological risk assessment really gave us a very valuable contribution. And one substance that springs to mind there is glyphosate, because there you actually have a perfect example of the value and pitfalls of human biomonitoring and biomonitoring in general. So despite an extensive toxicological characterization of glyphosate, there was little data on actual exposure at the time. And we had toxicokinetic studies which indicate oral absorption from low doses, such as you would find in residues of food and feed, to be somewhere below 20%. And then once it's absorbed, the absorbed parent compound remains basically chemically unaltered and is rapidly eliminated via urinary excretion. And that, of course, gives you the perfect option to validate your values, because you know how much urine a human normally in average produces per day. It's around 2 liters. And from that, you can calculate from the levels in the urine what the external exposure was. So coming to reports that you probably all know because they went all over the press, there were several reports showing glyphosate findings in urine, which of course, when you read it first from the headline, might be worrying. And there were several studies. I'm not going to go into the details of each single one of them, but it of course raised the question, is that now a matter of health concern or isn't it, in terms of human toxicological risk assessment? And I just make one short note here, because that's going to be important later on. Of course, when you do human biomonitoring, and in good human biomonitoring that's always the case, the method that you use has to be suitable for the matrix that you try to detect your analyte in. So from the toxicological side, we did a comparison of data from a total of 7 studies at the time. Those were data obtained from various countries, obtained with different methods and under different conditions. The number of participants ranged from 5 to over 300, and we tried to compare them as much as you could because, of course, each study has different starting points when it comes to study design and how the data can be interpreted. However, the mean urinary concentration was somewhere between 0.21 and 3.2 micrograms per liter, with maximum concentrations in one case of occupational exposure ranging to 233 micrograms. But to cut a long story short, in all those cases, the levels measured basically indicated to be only a fraction of the allowed daily intake, or in terms of the operator exposure still being below 10% of what would be considered to be safe. So that brings us to a point that is basically shared by all health-based guidance values when it comes to biomonitoring. And that's how to communicate those values and how to compare them to the toxicological expert assessment. So you have to effectively bridge the gap between the experts and the lay people. And there you have, from several studies, basically a list of factors that characterize how risk is perceived. And there are factors there that we spring to mind immediately, which is the scientific uncertainty. Of course, it will have an impact on how you evaluate a risk. The same for the immediacy, the familiarity, the potential for catastrophic results, and the severity of consequences or their reversibility. But then you have a list of factors which I would consider to be, from a scientific side, soft factors. That's the dread, so basically how much fear a risk can evoke, then if you're exposed to it voluntarily, if you have the feeling that you can control it, how much you know about it, and then the clarity of the benefits that you gain in taking this risk. And then, of course, attribution of blame. So when you have a risk that is attributed to humans, you normally consider that to be more severe than when it is a natural risk. And then, in the end, of course, how much media attention it attracts. And that brings us to a point where you basically run into a communication problem because people trust things that they do know. And I picked out this perception of nature as non-toxic, which if you study toxicology, know is not true. Actually, some of the most toxic substances that we know of are natural. Nevertheless, and that includes us all, from the perception, nature is good, the intervention in nature is perceived inherently as problematic, and health risks related to deviations of this state are perceived as particularly problematic. On the other side, you have chemical risks, and that these you normally evaluate to be of more risk than natural risks would be. And in consequence, for example, and that has been studied, most people will underestimate the risk from carcinogenic substances from nature, but will overestimate the risk of carcinogenicity from chemicals or pesticides. And that's exactly where biomonitoring values basically can kick in and help to bridge this communication gap, because they basically give a picture to that and a frame to what you find. So I give 2 examples. One example, which was very popular in the German press as well, is beer. We had findings of up to 30 micrograms per liter of glyphosate in beer. So you might wonder, is that then a risk? If you sit down and do the calculation, you see that to ingest harmful levels, one would actually need to drink 1,000 liters of beer a day, and I guess then you have other problems than the glyphosate in there. The same is true for breast milk. There were reports of glyphosate finding in breast milk, which turned out to be false in the end because the method that was used to measure those was not suitable for the measurements. But now, even if you just disregard that for a moment, the levels reported then, again, would have resulted in incredibly high amounts of milk an infant would have needed to drink in order to reach levels that would have been considered a toxicological risk. And for the actual risk assessor's point of view, so when you come and do the risk assessment, that's one of the several factors where human biomonitoring can really make a big contribution, that is reevaluate your results, basically see what you get, and then act on it. And with that, I come to the end. Thank you for your attention.